You're watching the video lesson titled Managing Virtual Networks with Power CLI. This is a part of the VMware vSphere Power CLI training video course. In this lesson, first we're going to start off with a bit of a mini tutorial on virtual networking. I've got a bit of a slant to put on it that will hopefully help you apply the concepts that you're going to learn with regards to managing virtual networking with Power CLI. Then we're going to talk about the overview of all the commandlets that are related to managing a virtual network. Then we'll start getting into some specifics, starting off with the network subsystem itself, then host network adapters, and then we'll talk about working with virtual switches and distributed virtual switches, and we'll round out with working with virtual port groups. What I want to explain to you about virtual networking and how this might differ from tutorials or other training material which you've used with regards to networking in vSphere is there's several pieces of it, and let me just run the slide through here. You've seen this a screenshot like the following before. This is a very basic part of your vSphere client, and this is one of several pieces. You've got, for example, the host network. This includes the basic DNS and routing settings, and I'm going to go into the VI client and show you exactly what I'm talking about in a moment. You have the host network adapters. These can be physical or virtual, and they serve as the link between the host and the switch. Very important to understand networking. Obviously, it's all about links. It's all about the relationships. In a physical world, you know, their cables and so forth, but in the virtual world, it's a little more abstract, so it's very important that you understand the relationships. Host network adapters, we're talking about just that relationship between the host and the switch. Then you've got a virtual switch. This is the link between the network interface card and the port group. And then the port group is also known as a virtual network, and that is the link between a virtual machine and a switch. Now let me bring up the VI client and walk around what I've just shown you. Okay, I'm going to go to my host configuration screen. I'm going to start off here under, this is just one of my lab hosts. Going to go to DNS and routing. And you can see several pieces of information here related to, of course, DNS and routing. This is what in the vSphere API, the application programming interface, is basically the host network. This is the part that's set up before ESX server is installed. You know, when you're first booting to a CD and running that install wizard, if you're going through that, that's this portion of the networking configuration right here. Then we've got other pieces. We've got the network adapters, both the physical and virtual, and we're going to be talking a lot about these in this lesson. This screen under network adapters is showing you only the physical network adapters, and you can see several different pieces of information about them here. And then under the networking tab is where you have this is where you spend most of your time when you are configuring a network. And this is basically where you have the virtual network adapters mapped to the physical network adapters and associated in blocks basically with a virtual switch. And then inside of each virtual switch you have one or more port groups. And you can have multiple different kinds of switches and port groups, and we'll go into some of this and how it relates to Power CLI shortly. But what I wanted to help you understand is that the way that you look at these in the VI client may be different to how you're going to have to work with them in Power CLI, and hopefully it will make more sense through the lesson. Back to the slides. Now we're going to be talking about the virtual networking commandlets. There are 4 categories that we're going to be working with in this lesson. These correspond to the nouns in Power CLI. Talking about the commandlet, that's going to be the portion after the verb here. For example, we've got 4, you can see on the screen, VM host network. That's made up of 2 different commandlets. VM host network adapter, there's 4 of those. Virtual switch, there's 4 of those. And virtual port group, there's 4 of those as well. Now, there are a few that we're not going to be talking about in this lesson, such as virtual machine networking related commandlets like get network adapter. Those commandlets were covered in the virtual machine lesson. And I do want to mention that while there is some support for distributed virtual switches, as of the recording here, I'm working with PowerCLI version 4.1, and there are plenty of things which you can't do using PowerCLI, at least using the commandlets as I'll be describing them. That doesn't mean you can't do it, but I'll talk more about what I mean and what limitations there are as we get further into the lesson. Okay, we're going to now talk about how you manage the host network. There's a bunch of commandlets which we're going to be talking about here, and I want to remind you that we're just going to start off in several different pieces. We've got, first up, the host network subsystem. Now in the VI client, as you can see here in the screenshot, under host configuration, then DNS and routing, this is what I'm referring to as the host network subsystem. It's made up of your host name, DNS, and some IP gateway settings. This corresponds to the DNS and routing tab in the vCenter client. And primarily we're going to be talking about the VM host network noun. There's several commandlets in this category, such as get VM host network. This is used to display basic host network configuration. I'll show you examples of these here in a moment. And then the very overloaded, shall we say, set VM host network. This commandlet does a lot of different things, such as you can configure the host network, you can change your host name, change DNS domain, DNS servers, change your DNS search domains, otherwise known as DNS suffix search order in Windows. You can also change the default gateway for your VM kernel network adapters. And lastly, you can enable or disable IPv6 support. Okay, let's go to the shell and work with some of these settings. Okay, I am already connected to my vSphere environment. Let's see. Yep, I've got my hosts there. So we're going to be working with host networks, the host network subsystem, which I did show to you previously. Oh, here we go, DNS and routing. So in order to get a handle on this, you have to start with a host. So the commandlets that we're going to be talking about, so just get VM host network, one of the required parameters is definitely VM host. So that's where you start. So let's start by just displaying these host network settings. Okay, running get VM host through get VM host network. Now, I will remind you that by default, in many cases, PowerCLI and PowerShell will output the results of a get commandlet in a table like this one. And don't forget, there's more information in here than you can see. Now, obviously, some of this is truncated. It's a little bit hard to read. So what I'm going to do is run the same thing again, but I'm going to pipe it through format list. And let's hit enter and see what we see. Okay, now we've got more information. I'm going to scroll back up to the top here and explain to you a couple of these properties. Some of them are a little bit redundant. The ones that I want to call out here are VM host. That's going to be the name of your host. And in my case, they're different. In your case, they're probably going to be the same. But we've got host name here and VM host here. The difference is that host name is what the ESX host knows itself as. It's as part of the networking configuration. However, VM host is what vCenter knows the host as. Just due to strange DNS or lack thereof, I added them as an IP address. Your situation is probably not going to look like that. VM kernel gateway, this is basically your default gateway. And again, these are some of the settings that you would have provided when you initially installed ESX during the setup wizard. So below the VM kernel gateway, you can see a few fields here that are empty. VM kernel gateway device, console gateway device. Basically, what you're seeing here are fields that are used for an ESX server, but not ESXi server. So you might find that there is information contained within these. And when I get to talking about the types of virtual networking adapters and physical networking adapters in a little bit, I'm going to go into more detail about what these mean. DNS address, you're going to have one or more IP addresses here that are going to correspond to your DNS servers. And I wanted to note something here. When you see this on the right, where we've got two values separated by commas and then surrounded with curly brace, this is a very typical PowerShell notation for an array or a collection. It just means that instead of one value, like this is one value, I've got two, or in some cases, more than two values. So you can see some of these, we've got multiple values separated by commas. So the curly braces are not a part of the settings themselves, they're just the containers, and pay no mind to them. DNS from DHCP, this basically is whether or not you've got DHCPs enabled, and if it is enabled, whether it's going to populate the DNS servers for you. A domain name, this is the domain name for your host server. And then I mentioned host name already. Search domain, if you do not provide fully qualified domain names, then this is going to be appended to DNS searchers, which your host is asked to satisfy. And then virtual switch and physical NIC, console NIC, virtual NIC, these are basically lists of objects. And these objects correspond to pieces which we'll be talking about in more detail here shortly. Again, console NIC, notice it's blank. That's because I'm running ESXi. If you're running the Big Brother OS hypervisor, then you probably will see one or more NICs in this entry here. And you're going to recognize these names if you've been around ESX for a while. Obviously, these are names of the network adapters, names of switches, and names of your VM kernel devices. And let's see what else we have here is IPv6 information. All these from IPv6 enabled, and then console v6 gateway, gateway device, VM kernel, v6 gateway, and gateway device. And lastly is extension data, which is where you can find some behind the scenes, even more a deeper level of information. And then this second table is basically just the same as the first, but this is for my second ESX server. Okay, so now that we've gone through an example of what is in the VM host network, let's see how we can modify some of these settings. So first thing I'm going to do is I'm going to narrow down the scope here. I'm going to make a change on only one of my devices. And I can do this by just hitting the home key and then typing in the name of one of my hosts. And I should, if I hit enter, I should get one back. I do. So let's take off format list. And we're going to hit home again and say $HN equals. Now I've got a variable which represents my host network, and I can easily pass this down the pipeline or as a parameter to the set VM host network. So let's look at the help for set VM host network. Okay. As mentioned before, this is used to update the specified virtual network. Going to show you a couple of the parameters on this commandlet. First of all, network. This is going to be mandatory, and you can either specify this on the pipeline or as a value to the network. And this is that $HN variable which we just created. It is in fact a VM host network info object. Okay, console gateway, VM kernel gateway. Let's see. Console gateway is how you can specify a new console gateway, and it's asking for a string. This is actually going to be an IP address, so that's talking about the gateway IP address for your console network. And then similarly, we've got a gateway IP address which you can specify for the VM kernel gateway. And then VM kernel gateway device, that's talking about the network interface card name. Now some of these I'm going to go by just very briefly here because I want to show you in some actual concrete examples. That's going to make more sense. We've got several here for working with DNS, such as domain name, got your host name, DNS from DHCP, that's a Boolean, which means true or false. DNS DHCP device. This is if you enable DHCP, then you're able to basically say which network adapter is going to be obtaining that information from DHCP. DNS address, and this is a string, and as I've mentioned before in other lessons, if you have a .NET type, such as string, followed by a couple of empty square brackets like this, that means that you can specify multiple values. So if you type in, for example, an IP address, comma, and then a second IP address, it's going to interpret that as multiple DNS servers. Search domain, again, you can specify multiple values to this. And then we have some information about IPv6, which I'd mentioned. So then we have some of the common parameters. So let's go ahead and make some modifications. Clear the screen. I've got $HN ready to go. And let's see. I'm going to remind myself some of the parameters here. Set VM host network using my venerable GPM function. Okay, so what I'm going to do is $HN, pipe that to set VM host network, like so. Now, by supplying $HN over the pipeline, PowerShell is going to map it to this network parameter here. Alternately, I could use this other format. Follow me here at the cursor, set VM host network -network $HN. So either way, it works interchangeably. I prefer the former, so we'll go back to that. Okay, now what I could do, I'm working with just one of my servers. I'm just going to edit the DNS setting, for example. So we have DNS address. I'm just hitting tab, by the way, and PowerShell is doing that magical tab completion for me. So DNS address, and I'm just going to type 192.168.1.1. And if I were to hit enter here, or I could supply multiples such as that, but I'm just going to do one. And let's say what if. What if you've not seen that before, this is a parameter which is built into most PowerShell commandlets. It's very handy. I'll type what if, and it says performing operation configuring VM host network on VM host, and it tells me the VM host name, which is a great sanity check there. So let's take off what if, and while I do that, let's see, hit enter, and if we bring up vSphere client, you can see update DNS configuration. Now, if we look at my primary or my other host, you can see I've got two DNS settings here, a 192 and then a 68 dot something. And on the second one, that 68 is missing. So that is the change that we just made. So that's all I wanted to show you for working with set VM host network. So let's get back to the slides. Working with host network adapters. There's a lot of meat in this particular section, and I'm excited about it because it can be confusing, but I think that I've got what I hope is the right way to explain this for you guys, and hopefully you'll get a lot out of it. So as you can see in the screenshot here, now we're in a different section of the host configuration. Instead of DNS routing, we're up here in network adapters. You can see here I've got a table showing a list of these network adapters, and they all start with vmnix something, vmnix 0 through 4 in this example. And some of the information which you see in the vSphere client: speed, link speed, duplex, MAC address, observe IP ranges. Some very important information, obviously, for working with networking of any kind. These are your physical, these are the real network adapters. Well, there's more than physical, there's also virtual network adapters, and we're going to get to that in a minute as well. I've got a lot of commandlets and a lot of syntax to show you and a lot of demonstration. Let's get into it. First, realize we're now talking about a new noun. This is the VM host network adapter noun. There's 4 of these commandlets. First one is get VM host network adapter, and this is to retrieve the host network adapters. New VM host network adapter. This is used for creating a new VM kernel or service console network adapter. And I'm going to show you examples of this and to clarify what I mean by VM kernel or service console in case you're not familiar with it. But note that those are types of virtual network adapters. You can't create a new physical network adapter. Then we've got remove host VM host network adapter and set VM host network adapter. And I'll show you demonstrations of working with each of these commandlets. Okay, get VM host networking adapter. As I mentioned before, it returns both physical and virtual network adapters. It has one mandatory parameter, and that is VM host. It has a bunch of optional parameters. Now, this is actually pretty cool the way that VMware did this. They haven't done this consistently across every one of their getter commandlets, but I think they're going to definitely be moving this way. So what we have here is a set of optional filter parameters. If you supply these filters, then you can limit what shows up. And this is important when you're working with, for example, physical and virtual networking adapters, because in the VMware space, you usually have a bunch of networking adapters in your servers. Sometimes you might just have a couple, but that's pretty rare. I've seen many cases where you've got 6 or 8 or more. Having the ability to narrow down the list programmatically is very important. So some of these parameters which we'll be working with here, you've got physical. If you specify this, you're only going to see the physical network adapters. If you we've got VM kernel. This is, if you set this flag, then you're only going to see the VM kernel networking adapters, as opposed to console, which is to display only the service console networking adapters. As I mentioned before, the console networking adapter type only applies to ESX, and the service console, or the management traffic, really actually travels over a VM kernel interface. So both VM kernel and console, those are two different types of virtual networking adapters, basically. Then we've got the ability to specify a name. You can see right here. So if you wanted to, for example, work with your second network adapter, which is usually going to be called VMNIC1, you could say, get VM host network adapter -name VMNIC1, and it's going to spit out only that second networking adapter. And you can get that, for example, across an entire cluster or an entire data center full of hosts, and it's real easy to do. And then we do have a distributed virtual switch parameter, and this will allow you to show the adapters by their DV switch relationship. So for example, if you wanted to only display the networking adapters which are used as uplinks to a distributed virtual switch, you can do that here, and I'll show you examples of that in a moment. In fact, that moment is right now. Let's go to the shell. Okay, I lied. I decided not to go to the shell first. Instead, we're in the vSphere client, and what I want to show you here is the realm, the area of vSphere client that we're going to be talking about with the VM host networking adapter commandlets. So we've got networking adapters here. These are the physical ones from VMNIC 0 through 4 in this particular example. And we're going to be working with the get VM host network adapter commandlet, and it returns both physical and virtuals. So the physical ones show up here, and the virtual ones actually show up here under the networking tab. Now, if you look here in gray, under each of these port groups, we've got a little designation here before the colon: VMK1, VMK0, VMK3, VMK4. Those are the virtual networking adapters, and those note that they have IP addresses assigned to them, as opposed to these networking adapters here, which don't have IP addresses assigned, although they do have visibility to IP addresses. So we'll explain that a little bit. Okay, now we can go to the shell. And again, let me clear my screen. We're going to be starting with a host. So let's say get VM host. Pipe that to get VM host networking adapter. I'm going to hit enter. And you can see 2 chunks of information. And that was for my first and for my second. So this block here at the top, this is for my first ESX server, and the block at the bottom is for my second. And you can see we have 2 different types of information here. Obviously, the names correspond to what I showed to you in the vSphere client. We have the physicals, which start with vmnic, and then we have the virtuals, which start with vmk. And you may see some other results. Your results may vary. If you're working with an ESX server, you might see a different designation for your service console networking adapters. I don't have an example of that in front of me. Now, I would note also, we've got IP addresses assigned to our virtual networking adapters, but no IP addresses assigned to our physical networking adapters. Let's take an example of one of these. Let's just look at, well, you know what we're going to do? We're going to start exercising those different parameters which I mentioned to you. So if I just type physical, you can see there I've got just the physical networking adapters. VM kernel, it'll pull up just the VMKs. Okay. And let's see what else we have here. Okay, you can see we've messed with physical, VM kernel, console. I'll show you console, although it's not going to do anything in my case. And as you can see, it didn't. Now, one thing to note here, and this is something that is definitely a common convention with PowerShell. When I asked the system to give to me all of my networking adapters which were a service console type, I didn't get anything back at all. No error message, no result whatsoever. Some scripting languages, some different utilities, programmed by other people, and using different languages and so forth. You might get an error message here. You might get a prompt, are you sure this is what you want to do, or whatever. In this case, PowerShell, there's a good reason for it, but you're not going to get any output by default. The reason is that you can use values that are returned, let's say C equals console network adapters. C has nothing in it, but what I can do, I can say if $C, then do something. This is some PowerShell pseudocode. It basically just says, if there's anything in this variable, let's do something to it. Whether that is, modify it using the set vmhost networking adapter commandlet, perhaps, whatever the case may be, whatever you want to put in that curly brace. So if nothing is returned and there's no error messages, then I'm able to programmatically carry on and just work with that. If I received an error message, well, then I would have to think about how to handle that error message in code. And this is there's other ways that other languages treat this sort of thing, but as I said, this is a very common thing in PowerShell. If you ask for something and there are no results, you'll just get nothing, no error message. So we've gone through these different variants of working with the Get vmhost networking adapter. Now let's play with distributed switch. Let me see. I think I've got one in here. Let's look in under my networking. Yeah, I've got one called ent_exam. So let's see. What we could do is, okay, so we know we've got a DV switch named ent_exam. So I'm going to skip ahead a little bit with you here, and we're going to work with the get virtual switch commandlet briefly. We're going to talk about it in more detail later. So let's say name ent_exam. Okay, now I've got an object called DVS here, and that's got a reference to my switch. So what I can do with this, let's look again at the syntax. Get vmhost network adapter. And we've got two parameter sets, two modes. We have the default mode and the distributed switch mode. So in the distributed switch mode, it expects you to pass it a distributed switch object as opposed to vmhost object. So I've got a DV switch right here. Let's pipe that straight to get vmhost networking adapter. So I don't have to specify a vmhost. With me? Okay, let's try this. Now, what this has done has shown me on my virtual hosts, the networking adapters, which of them are connected to the EntExam DV switch. Let me show you the equivalent of this in the vSphere client. So basically there's a couple different ways to look at the same information, but I'm going to go to Edit Settings, Networking Adapters, and you can see here's the host. We've got 1, 2, host, 1, 2. So this is the information that we're receiving here when I query by a DV switch. So it's good information to be sure. Another way to look at similar information is you can kind of work it through by going to EntExam and then to hosts. You can see the hosts, and you could click on the host and go to under networking and stick with me. Click on the virtual networking vNetwork distributed switch, and then scroll over here. You can see we've got multiple uplinks, and I can hit the plus sign, and there are those networking adapters. So as you can see, that took several steps. Either way, that took several clicks in the GUI to find out the information, which was actually very easy to figure out once I knew the name of my distributed virtual switch. So let's get back to VM host networking adapter. Okay, we have looked at the physical VM kernel console name and basically done it all. So that is that commandlet. Oh, I promised you, determine link state of physical adapters. I always deliver on my promises. Let's see. If we want to determine the link state, that applies to a physical networking adapter. So let's start there. Okay, VM host network, physical. Oops. There we go. Physical. Okay, what I'm going to do is I'm going to assign those to a variable. Let's call them, say, pnic equals. Now I should have a bunch of those. Let's see how many I have. Pipe these to the measure object commandlet in PowerShell. Oops, no wonder that didn't work. Let's say pnic. Okay, I've got 10 of them. And before I do anything else, I want to examine these guys more closely. So let's pipe them to get member. Obviously, I have an attachment to the letter P. Okay, now the physical networking adapters have different properties than the virtual or the VM kernel networking adapters. The important ones here that I want to talk about here: bitrate per second, device name, DCP enabled, and full duplex. We've got IP, MAC. We've got a lot of interesting stuff. Tell you what, we're going to do pnic, pipe that to format list. Okay, I got 10 of those flying by on the screen. So bitrate per second. This is obviously talking about the speed of your network, and I'm connected to a gigabit switch, so that's why we see 1,000 here. And they're configured as full duplex. You can see Wake on LAN supported or not. And we've got the name of the host associated with the device name, which is here very clearly. We've got MAC address, whether DHCP is enabled or not. And as these are physical networking adapters, the way that I've got these things set up here, we're not going to see an IP address or a subnet mask. That's not, they aren't associated with physical networking adapters. Those are the virtual network adapters. So this is just, this is going to be blank most of the time. And then name, that's corresponding here to device name. So what I want to do is determine which of my physical NICs are down. The way that this is done, let me show you the vSphere client. And let's go to host, networking adapters under configuration here. The way this is done is this column right here, speed. You can see it says down. So there's no, well, there's another way to show them whether or not a NIC is down, and I showed you this a moment ago if you were paying attention. You'll see a red X next to it. So two ways: either you see a red X next to it there, or under network adapters, you'll see down under the speed column. So back in the shell, if I scroll up through these, you should see one of these with an aberration, and that's going to be this guy right here. So this particular network adapter, VMNIC2 on my second ESX server, has a bit rate of 0. So that does definitely correspond here. VMNIC2 down. So programmatically, how do we figure this out? We're going to use a commandlet called whereObject. So I've got my PNIC all set up. Let's pass this to whereObject. WhereObject commandlet is a filter. So what you can do is you can specify something inside of a couple of curly braces, and you can basically determine whether or not you want things to pass through this filter and to move on in the PowerShell pipeline. What we're going to do is we're going to access the bitrate per second property and just going to basically say $_ bitrate per sec less than, well, there's a few different ways of doing this. I'll just say less than 1,000 for the moment. I'll show you a couple other ways, things you can do here. So what this did was very quickly gave me the answer to the question of which of these were down. Another way that you could do the same thing, we could say if there is anything at all. So let's see. Let's do it this way. We'll say -not and then $_ bitrate per second. Same thing. So what I've done here is said, is there anything in the bitrate per second property? If there is anything in it, I don't care. I don't want to see that. I want to see the ones where there is not anything in it. So that's what the not operator here. Now another way you could do the same thing, some people may be more familiar with this syntax, is the single exclamation point. So PowerShell will accept either that or -NOT. So this is a quick way that you can find out which of your NICs have a down link. Now let's go back to the slides and we will carry on with our presentation. Okay, now we're going to talk about the new VMhost network adapter commandlet. This commandlet is used to create a VM kernel or service console virtual network interface card, otherwise known as NIC. So as you can see in this little screenshot here, which is kind of small and blurry, so let me just bring up the big boy here. I'm going to go to my networking under configuration tab here and click on add. And I'm on ESXi, so I only have two options. I have either virtual machine networking or VM kernel. If you are running an ESX server, then you will see Service Console as an additional option. This is the screen that I'm talking about that corresponds to the new VMhost networking adapter commandlet. So as you can see here on the screen here, it says that this is used for vMotion, iSCSI, NFS, and host management. In the case of, and we'll see on the screen here, in the case of ESX, then the host management traffic is going to happen over the Service Console. So now that we're straight what this commandlet is used for, mention a couple of the important parameters. VM host, which you should be familiar with. IP is just going to be the IP address for this network adapter. Subnet mask, port group, virtual switch, MTU, console NIC, and vMotion enabled. These last two, console NIC and vMotion enabled, those are Boolean, those are flags. They can either be on or off, and they correspond roughly. Well, if you supply console NIC, you're going to get the equivalent of pressing this last button here under Service Console. And if you don't, then you'll get a VM kernel device. Now, not every VM kernel networking adapter is vMotion enabled. That's definitely an option. And I'll show you that screen here shortly so you'll further understand. Some of these other things I skipped over: port group, virtual switch, and MTU. You can use MTU if you wanted to, for example, use jumbo frames. This is might be useful for your vMotion network. And port group and virtual switch, this is so that you can specify to which virtual network adapter that it will be connected to. Okay, so let's go ahead and create a vMotion network. We'll bring up the shell right now. Okay, let's start with the hosts. Okay, as you saw in the previous demonstration, I've got a bunch of these created already. We're going to just create one more. Let's look at some of the examples of the new VM host networking adapter. Okay, so I'm going to use the examples parameter to the help commandlet, and that will just spit those right up. So you can see we've got, this is a definite great resource with PowerShell and PowerCLI, the ability to pull up these full examples. We've got the explanation, the syntax, and further elaboration. This is some great stuff in here. So I want to remind and encourage you to go through these examples when you get a chance. It'll definitely help round out all your knowledge. So what I'm going to do here, let's clear the screen though. Okay, so new VM host network adapter. It has a lot of parameters. I mentioned many of them already. There's a couple I didn't mention before, such as fault tolerance, logging enabled, and some of the IPv6 things, and then management traffic enabled. So the converse of console NIC for ESXi is management traffic enabled, and that corresponds. This one only works for ESXi. This one only works for ESX. So hopefully that makes sense. So what we're going to do here is our aim is to create a new vMotion networking adapter. And in order to do that, usually you're going to want to know which switch it's going to be configured to connect to. So let's go ahead and look at that. Under configuration, go to networking. And I'm just going to pick a vSwitch at random here because this is my lab and I don't care. But you, of course, are going to have some definite needs, and you're going to want to obviously understand which physical networking device is my vMotion network going to be going out on, and is that physical device already a part of a virtual switch, or do I need to create a new one, so on and so forth. But in my case, I'm just going to use vSwitch 0, and we'll go from there. And remember, your vMotion network has to have an IP address assigned as well. So in fact, let me show you an example of one. Yeah, here's my vMotion network. You can tell because it says vMotion and it's enabled right there. And you know that this is ESXi at a glance because I've got a network labeled management network, and then it has management traffic enabled. On ESX, it'll actually say service console instead of management network. So anyway, some of the settings you can see here, IP settings, we've got IP address. So we're going to specify the very same thing using PowerCLI. So what we're going to do is get VM host, and we're going to save that as H equals. So now my ESX servers are in the H variable. And what I'm going to do is I'm going to just start from scratch with new VM host network adapter and see if I can't build a successful syntax. And let's see, we are supplying the value for the VM host parameter on the pipeline right here. And what I'm going to do is we'll say vMotion enabled. That's definitely going to be true. And then IP. I'm just going to make up a... actually, that's not going to work because that'll actually make them the same for all of them. What we're going to do is, instead of H, we're going to say get VM host. Now I can show you an example afterwards about how you would do this for multiples, but just so we can get through this particular example, subnet mask 255.255.255.0, and let's see, virtual switch v switch 0. Okay, let's see if this works. It doesn't. vMotion enabled. So, as I mentioned, this is a true-false flag, and I didn't supply the value here. You'll see this is different for, in PowerShell, there's a couple different parameters which work similarly, but they're not identical. Boolean, and then we have switch. Boolean, you have to explicitly mention true or false, so I'm going to do that here. So I've got dash vMotion enabled, followed by a colon, and then $true. I could also put $false. And okay, we got an error message that says you have to specify one of the parameters, port group or port key. Now let's go back over here under, I've got a port group called VM kernel under the vSwitch 0. So let's try that. I'm just going to add on dash port group and VM kernel, like so. See if that works. And I know that it is because I can see a little bit of action happening in my vSphere client. So what we see here is that in the bottom of the vSphere client, I've got multiple things that happened. I've got add port group, add virtual NIC, select vMotion virtual NIC. So a few things happened at the same time. And you can see it's done here. So now I've got a new one called VMK6. Let's go back to our vSphere client and click on refresh. And I should see a VMK6 in here somewhere. If I'm looking at the right one, I think I may not be. Yeah, I'm not looking at the right one. So let's go back to the first. There we go. Okay, so now we've got a new port and port group and vSwitch 0. And you can see my new one with the 192.168.0.23. And if I go to properties, we should see that it says vMotion is enabled. So what if I wanted to disable that one? I hadn't planned on doing a demo of that, but it's very easy to do. So let's say get vmhost 1.11, get vmhost networking adapter, name VMK6. Hit enter. And you can see I got the same result back exactly. Let's pipe that to remove. vmhost networking adapter. Hit enter. Now, this might not work. I'm going to go ahead and hit enter and see what it does. And the reason it might not work is because of some of the relationships between objects. Okay, it did. I have seen cases where you couldn't remove one piece without removing another piece. For example, if I tried to remove the port group, it might have told me that I can't remove the port group because it's not empty. Or remove a vSwitch. You can't remove a vSwitch unless there's nothing in it. So as you can see, the VMK6 device is gone. So I just wanted to show that to you. Okay, let's get back to our slides. Now we're going to talk about the set vmhost network adapter commandlet. This commandlet is used to modify a physical or virtual host network adapter. In physical mode, you can modify the duplex, link speed, or auto-negotiate flag. These are very basic network settings which you're probably very familiar with, but just in case you're not, you can set your duplex to either full or half. Your link speed can be an integer. It's usually going to be 10, 100, 1,000, or higher in some cases with the latest networking equipment. And then auto-negotiate is either enabled or disabled. And if it's enabled, you're not going to set those first two settings at all. If it's disabled, then you are going to set those first two settings. Virtual NICs have different things that you can modify. We've got your IP addresses, DHCP, whether that's on or off, the MTU, which is maximum transmission unit, vMotion, whether you can pass vMotion traffic on this virtual NIC or not, fault tolerance logging, and management traffic, and those are also Boolean switches off or on. So a lot of different things you can do with this commandlet, and I'm going to show you a demonstration of how you can configure your physical host network adapters right now. Okay, I've got my vSphere client up. We're looking at my second ESX server on the configuration network adapter tab. Looking at VMNIC 4, you can see the speed is set to 1000 full. And what I want to do is try to alter that setting. It's the equivalent of finding the network switch to which it's a member, in which case I don't have one. So let's make it vSwitch 2, add VMNIC 4. And yes, you can do all this with PowerCLI, but I don't want it to teach you things out of order. So we're just going to do this real quickly in the GUI. Okay, so now you can see here that I've got 1000 full. If I double click there, this is the setting that I want to change. And here are the options you can see there. So I'm going to leave it at 1000 full for now. And you can see I just did update virtual switch. Let's go to the shell and see what we can do. So let's see, we're going to work with vmhost 12, which is my second one. Get vmhost network adapter, and then we'll say name vmnic 4, I believe is the one. Okay. And if I look back on this other page, looking at our vSwitch 2, we see vmnic 4 1000 full. Now, what I can do is let's call this just the letter N. So N equals, and I'm going to pipe N to format list, and you can see here bitrate per second, full duplex, and so on. So let's take N and pipe that to set vmhost network adapter. And we've got our options here: duplex, bitrate, auto negotiate. We're going to set that to false, and then bitrate 100, and then duplex half. And it's asking if I am sure. I'm going to say yes, I am positive. Okay, that's done. Let's do this where we assign this N device, again, N variable, and pipe that to format list, which is in this case aliased to FL. And you can see it says bitrate 100, full duplex false. And if we go to the vSphere client, we can see update physical NIC link speed. And sure enough, it says 100 half. And if we go to network adapters under VMNIC 4, we see the same thing. So that is how you do it. Let's go back to our slides. Okay, we finished up with our demo on configuring physical host network adapter cards. Now we're going to go back and we're going to work with virtual host network cards. I've got a pretty cool idea for a demo, and it is inspired by this blog post. Let me bring that up real quick. This is on VMware Networking blog, and it is titled Jumbo Frames in vSphere 4. So it's a pretty cool article. Just kind of lays out what is a jumbo frame. And you might have noticed that I talked about an MTU parameter before. That stands for maximum transmission unit. So I'm not going to go over the whole article, but if you want to enable jumbo frames in your environment, you're going to need to change that MTU setting. And you're going to have to do it not once but twice. You're going to have to do it on the virtual switch and on the VM kernel ports. In this case, this is basically the virtual network adapter. So you have to do it on your physical switches as well, but that's obviously outside of the scope of this demonstration. So let me bring up my shell, and let's see. We've got our H right there, so we're going to go H get vmhost network adapter, and I'm going to say vmk. Hit enter and show you what this does. Okay, so I've got my about 10 different network adapters. Now this is just for the sake of argument. In my case, I'm not going to say that you would want to, for example, modify all of your network adapters at once. Obviously, you're going to want to take care in preparation and so forth. But I'm just going to say, let's say that VMK4, if my cluster were configured identically, and VMK4 corresponds to, for example, my vMotion network. So what I could do is say, let's grab all these vMotion virtual network adapters called VMK4 and then pipe into set vmhost network adapter, and change the MTU to 9,000. And you'll see, yes, I am sure. I actually hit enter, so that took the default of Y, so it's going to prompt me again. Since I have two of them, it'll just do that twice like so. And if we bring up the vSphere client, you can see there it says update virtual NIC. Now, the article does go on to say that you have to modify the VM kernel ports and the switches. So I will talk about switches later, but the concept is very similar. So that is all for that demo. Let's go back to the slides. Okay, now we're going to be working with virtual switches. Virtual switches are one of my favorite subjects. I'm going to switch over to the vSphere console here before I talk about the slides. Wanted to give you a refresher here, what I'm going to be talking about in configuration under networking. You've got a list of virtual switches here. These are the top level items. If I go to properties, you can see that we've got a collection of things inside of a switch. This is the switch itself, and the settings on the right are over here. And then we have a list of port groups, which we will be talking about after the switches. And switches have a network card assignment, and that's this. This is the physical network card assignment for this particular virtual switch. And if you highlight one of these and go to Edit, you can then change some of the settings, which you can see here on the right-hand side summarized. So we're going to be talking about commandlets, which can allow you to modify some, but unfortunately not all of these settings, which I'll show them to you in just a moment. Let's go back over to the slides. Okay, the commandlets we're going to be talking about first off is get virtual switch. This one allows you to retrieve information about a virtual switch, and we've got the normal set of helpers such as new virtual switch to create a new virtual switch, remove, and set. That is used to modify an existing virtual switch. In addition, I've got two special helpers here, get NIC teaming policy and set NIC teaming policy. These are used to retrieve or modify the NIC teaming, load balancing, and failover settings for a switch and for port group. So these same two commandlets, these here get and set NIC teaming policy, they work for vSwitches or port groups. Okay, I wanted to focus a little bit on the new virtual switch commandlet. You can use this one to create a new virtual switch. Note that as a version 4.1 of Power CLI, you cannot use it to create a new distributed virtual switch. Has a couple of important parameters. By a couple, I mean 4. We've got VM host, name, that's going to be the name of the switch, number of ports, and NIC. And NIC can be a string or an object, and I'll show you an example of using that in just a moment. One thing I did want to mention about the number of ports, you may realize this. Let me flip over to my vSphere client again. When you go to the properties of a switch and you try to modify the ports, look at this right here. Changes will not take effect until the system is restarted. So of course, what this means is that you want to be very certain that you know what you are doing when you're specifying the number of ports up front, because restarting an ESX server is a big deal, and you don't want to do that indiscriminately. So just be sure that you've put some breathing room in when you're specifying your ports. So let's go to our shell, and I'm going to show you a demonstration of how to create a virtual switch and assign network cards to it. Okay, before we get into the demonstration, I want to bring you to the vSphere client and look at a couple of things. First off, we're going to be working with VMNIC 4 and 3. These two are not assigned to a switch, as you can see here on the switch column is none. And if you go to networking, if you peruse the list of switches here, you'll see that nowhere does VMNIC 3 or 4 do they appear on the right-hand side under physical adapters. So with that, I'm going to go ahead and open up the shell. And you might be wondering, is there an easy way to find out the answer to that question? Which physical adapters do I have which are not assigned to a switch? And first, let's use some of the commandlets which we've used previously, such as get virtual switch. And you can see that we've got some output here related to the number of ports and the MTU and the name. Let's pipe this to format list and see if I got any more information, and I do. Now what you'll notice is that there is a NIC property here, but it's blank in some cases. What I'm going to do is pull out some of this information and put it into a table that so that it will be a little more useful. So we're just going to grab name, NIC, MTU, just for the heck of it. Okay, now, so I've got switch 0, 1, and 2 on both my VM hosts, and I've got a DV switch called ent_exam. And notice that the NIC column is empty, and switch 1 and 2 has no assignment on either of these. Now, if we look in the vSphere client, you'll see that, for example, switch 2 rather, has no physical adapter, switch 1 has no physical adapters. So that is correct. However, if you go over here to the distributed switch, you'll see here that we in fact do have VMNICs 1 and 2 assigned to a DV switch. Or you can get the same sort of information here under network adapters. There you can see ent_exam is mapped to that DV switch or to these physical adapters. So you're not seeing the correct information where you'd expect it to right here. These blank fields, that is correct, but you're not seeing the full picture. So just realize that as a version 4.1 of PowerCLI, you don't see the assignments for distributed virtual switches, and it's not actually super easy to see this same correlation between the physical network adapters and the switch. It's just not a perfect picture right now. I have actually made requests to VMware. Hopefully we'll see an improvement to that in the future. For right now, I just want to kind of set you up with that. Now back to the demonstration, which is namely create a virtual switch and assign network adapters. So let's look at the new virtual switch commandlet. And there it is. Okay, create a new virtual switch. We've got parameters such as VM host, and we have name. These are two very straightforward commandlets or parameters. Then we have number of ports, and as I mentioned, you want to make sure that you've got a good starting base here. You don't want to shoot too low on this number. And then we have NIC. This is an optional parameter, but if you supply it and then with the name of the NIC, then you'll be able to make that assignment all in one go. So it's creating the switch and then making that assignment in one command. And you can also specify the MTU. As I mentioned previously, you've got, if you want to do something like jumbo frames, you do have to set that MTU on both the switch and the NIC. So that's a couple places you need to be sure to do that. And then we've got the standard server, what if, confirm, these parameters that are not that special. So let's go see what we want to do. Let's get VM host and create a variable, call that H. So H is right there. And let's look at one other thing on new virtual switch. VM host is a singular. Notice that there are no square brackets after it. And if I scroll up to the help, you'll see the same thing there, right around here at the top, I believe it was. There we go. So this is where that piece of information is coming from. So this means that you cannot supply multiple host servers to this commandlet. You've got to do them one at a time. So you might ask yourself, okay, what am I going to do if I want to create new virtual switches across all of my environment, or several VM hosts? And it's not hard to do. And I'm going to walk you through this on the command line. Now realize that anytime that you're going to do anything that involves multiple steps, you might feel more comfortable placing those steps in a text file or in an editor such as a PowerShell ISE or any of the other great ones out there. But I like doing stuff with the command line, so I'm just going to do it, kind of shoot them off here. But let's just say we're going to pipe H to the for each object commandlet. And inside of that, we have a script block, and we're going to say new virtual switch. And then we've got the various parameters that we have to fill out, such as names. So we're going to call this v switch 3. And then we're going to say num ports 64. And NIC is going to be, if you recall, let's go back over to our VI client. And 3 and 4 on both my hosts are unassigned. 3 and 4, you can see there. So we're going to do vmnic3 and vmnic4 in the same go. Here's vmnic3, vmnic4. And I'm just going to separate those with commas. And that's it. I don't want to specify the MTU in this case. And then I just have to close that off with a closing curly brace. And let's hit enter and see what happens. And of course, I forgot to specify my VM host. So let's just tack that on here. And the way that you do this inside of a for each object loop is whatever is on the pipeline. So this is $H, this is a list containing my VM hosts. Those are replaced inside of the curly braces with $_. So if we do it like that, then it is as if we are typing in the name or the reference to each of those host servers right there. So I'm going to hit enter and try this again, show you what it does. And now we should see some action. Okay, there we go. Okay, and we've got 2 new switches, so let's grab those using get virtual switch name. Let's see, v switch 3, and pipe that to format list. And you can see right here under NIC, vmnic3, vmnic4 in both cases. So that is a pretty solid way to create a switch and then assign the physical network adapters across multiple hosts in one go. And if we do a refresh on this screen here, you should see this switch none change accordingly. So let's go back over to networking. Refresh. Scroll down. There we go. We've got 3 and 4 right there. So let's go back to our slides. Now we're going to be talking about the set NIC teaming policy commandlet. You may recall, we mentioned this a couple of slides ago. This is how you modify the NIC teaming properties. Here's an example of the screenshot here. The configuration settings or the properties of a vSwitch. And there's a tab here called NIC teaming, and it's got a bunch of different things in it. You can use this commandlet to modify pretty much everything on this screen. In fact, there's a setting in here that you don't see on the screen that you can modify as well. That's going to include the load balancing policy, failover detection policy, switch notify policy, the beacon interval, which doesn't appear on this screen, and the failback policy. So this is basically the set of list boxes right here. And this deals with what happens when I have a problem with one of the physical network adapters connected to a switch. Is it going to fail over? How is it going to determine if it needs to fail over? Will it fail back when that link comes back up, and so on? And you can also alter these assignments here at the bottom of the screen where you see active adapters, standby adapters, and unused adapters. So this is basically adding to or removing from the pool of available network adapters, such that you can say that I want to always start with vmnic 0 and only use vmnic 1 if vmnic 0 becomes unavailable, as opposed to sharing the load across multiple NICs by placing multiple NICs under the active adapters list here. And lastly, this works on both switches and port groups. And before I go into the demonstration, let me show you what I mean and how it's a little bit different on port groups than it is on switches. So I'm going to go to the properties of a switch and go to the edit screen here. And under NIC teaming, you can see this is where that screenshot came from. Now let's do the same thing on a port group. You can see there's a NIC teaming tab, and there's a checkbox here. And you can see that this is grayed out. If I check the box, then it will allow me to edit the settings. What this is saying to you is that this screen is a policy, and the policy is inherited by the switch. So the port group, by default, because all these boxes are unchecked and the settings are grayed out, by default, we're going to do whatever the switch does. So this is going to be your overriding policy under the switch properties. But if you go to the port group policy, you can override or make exceptions to the policy. And you can also do the same thing here with the failover order. You can override that switch failover order. So the settings are the same, but they can optionally be overridden at the port group layer. And you can see this reflected when we look at the syntax of the set NIC teaming policy commandlet. So let's go ahead and do that. I'm going to show you how to modify these policies. Okay, let's see. We just created a switch, and it was named vSwitch3. You can see those here. So let's just say vs equals. Okay, now I've got a handle on those guys. And before we go further, let's look at the syntax of these two NIC teaming policy commandlets. So first I'm going to type git command, and I'm just going to say NIC, let's see, team asterisk. Okay, so now I see there's two of them, git and set NIC teaming policy. So let's try running git NIC teaming policy by itself and see what happens. Okay, parameter set can't be resolved using the specified name parameters. That doesn't give me a whole lot of help. So let's go to help, for example, git NIC teaming policy, and see what we see. And what I see here is virtual switch. And that looks pretty important. So let's see, we have to go back over here, and I have virtual switches, right? I've got them right here under VS. So let's do VS and pipe that too, git NIC teaming policy. Sure enough, I've got some output. So let's examine this in more detail. So I'm going to call that P equals. So now I've got my NIC teaming policy in an object called $P. And let's pipe P to format list, alias to FL here. And I will go over these properties with you. So I'm going to skip over the ones that aren't that important, like the ID. Okay, so virtual switch, this is corresponding to the switch name. And I haven't set a beacon interval, so you don't see one there. So there is one here, set to 1. Load balancing policy. It says load balance SRC ID. And top of my head, I could probably figure out what this means, but let's not guess. We're going to go back to the GUI and look at one of these switches and figure it out based on what we know right here. So we're looking at the load balancing policy property. So here, this is the load balancing option here, route based on the originating virtual port ID. And you can see some of the other options here, route on the IP hash, route on the source MAC hash, or use explicit failover order. So we know that this is the answer to the question. Let's go back to our shell here, load balance source ID. So I'm going to show you when we get to the set commandlet, what are the options and what are the special keywords. For now, you know that load balance source ID is going to be the equivalent to route based on the originating virtual port ID. So failover detection policy, right now it's set to link status for this one. Let's go back over here. Network failover detection, link status only. So our options are that or beacon probing. And you're not going to want to use beacon probing unless you've got, I want to say 3 or more physical network adapters assigned to a virtual switch. That's a best practice that I seem to recall reading. But link status only is the default. Notify switches is set to true. So you can see here that corresponds to this, true or false. And then same thing here for failback enabled, true. So you can see that's just a yes or no value right here. Active NIC 3 and 4, and you recall that we set this explicitly using the new virtual switch commandlet, so that's great. This is exactly where I expected this to be. Since I created them and did that assignment right in one fell swoop, the assumption here is that I wanted them both to be active. So that's what happened. And I've got nothing in standby, nothing in unused. You can see that this is not the same switch. So let's go to the same switch, which is the new one. Here it is, Virtual Switch 3. Go to Properties, double click on that, click on NIC Teaming, and there you can see NIC 3 and 4 are active. So go back to our shell. And let's see, check beacon is false. And then we have a couple of extraneous fields, and you can see the same thing repeated here for my second policy. So everything matches up really well. The exception being the beacon interval, which is not present in the GUI at all. I'm sure it's in there somewhere under an advanced settings screen. I'm not going to go searching for it right now, but suffice to know that you do have the ability to specify that using the set NIC teaming policy commandlet, which I'll show you right now. So that is how we obtain a policy using get NIC teaming policy. What if we want to modify them? So we've got P right here. It's got the information that we're interested in. I think what I want to do is let's move VMNIC4 from active to standby. And that way we can have a preferred path for whatever reason in your environment. There's plenty of reasons to do that. So we're gonna use the set NIC teaming policy command. So let's look at it. Okay, it's got a lot of parameters, a couple different parameter sets. As I mentioned before, we can use this on both switches and port groups. So I'm going to give you the full treatment here and show you the difference. First, let's just look at this top set here, the ones that correspond to switch. First and most important parameter is going to be virtual switch policy, and that is basically the this right here. It's the output from the get NIC teaming policy commandlet. And that's what this means here. And notice it's got a couple of square brackets there, so you can pass multiples of these, and you can do so on the pipeline. So good stuff. You can modify the beacon interval. So this is going to be an easy way to set that if you need to do that in your environment. You can change the load balancing policy, network failover, detection policy, and these are going to be what are called enumeration. So we've got a set of acceptable values. And I happen to know that those are in the help file, so we'll go look at them in a second. But first I want to finish up the rest of these. Here we've got notify switches and failback enable, which are Boolean. That's just true, false, yes or no. Real simple to understand that. And then we have make NIC active, make NIC standby, and make NIC unused. So this is how you do the movement of a physical network adapter from one place to another. And you can see here that we can specify one or more NICs to each of these parameters. Now, that's how you do it for switch. If you want to modify a port group, and remember that what you're doing there is creating an exception to a policy, or you're overriding a policy, you're going to use these similar but different settings here. What you have to do is you'll use your for example, your make NIC active, your notify switches setting. You'll make those settings changes just as you did above. However, you have to team it with, for example, the inherent load balancing policy, inherent failback policy, and you have to supply a true or false value. So this is, if we go back to the vSphere client, this is exactly the same. Let me go to one where I've got a port group. That's exactly the same as this checkbox. This is that true or false value. So if this is cleared, that's false, and that we are not going to override, or rather, let me correct myself here, inherit or not inherit. So this is actually the inverse. So to make sure that we're clear on this, if you want to inherit failback, then you're going to set this to true, and this implies that you're not going to set a failback. Does that make sense? So if you want to override some of these settings, then you're going to have to come in here and set these inherent flags here to false. So I can show you an example of that. Before I do, let's go back up here, and we're going to look at these two parameters right here, load balancing policy and network failover detection policy. So let's look at the help for set NIC teaming policy. So I'm just going to type help. I'm going to type it correctly. Set NIC teaming, and I just NICT tab, and it comes right up. Dash full. Hit enter. You can see here that large list of parameters here. And let me see here, spacebar. Here we go. Here's the first one, load balancing policy. And if we just scroll down a couple lines, okay, this is exactly what we wanted to know. Here are those keywords that you have to use based on and what they correspond to. So if you recall correctly, this is load balance source ID. This was the default that was on my virtual switch right now. Route based on the originating port ID. In fact, this is the exact string that you see in the vSphere client. And accordingly, you see the same thing here under these other options. So that's load balancing policy. We hit spacebar, and we see something similar here for network failover detection policy. The two options are link status and beacon probing. And if I scroll back over here, go to my switch, NIC teaming, and we've got failover detecting is link status only or beacon probing. So that is the exact same thing. And notice we do have some pretty good descriptions of what's going on. In fact, this is more than you see in the GUI. You'd probably have to go and hit help over here, which I'm not going to do, to get a full description like this. So that's good to have that right here in PowerShell without having to open another window. So feel free to read that at your leisure. So what we're going to do is let me scroll through. You can see here the failback enabled Boolean, and I'm not going to. Let's skip to the examples. So instead of full, we'll do help set NIC teaming policy minus examples, and we've got exactly one example. And here's how you can do that. But I'm not going to use that example. I'm going to do it myself. So recall we've got our P here with our policy, and let's modify them. Let's take that. Let's take VMNIC4 out, and we're going to make it standby. So pipe that to set NIC teaming policy, and I'm going to make it standby, and we'll just say VMNIC4. And that's probably going to be it. Let's hit enter and see what happens. Dramatic pause. There we go. And you can see immediately right here under standby NIC. So if I'm going to scroll up a little bit and show you the before, here's the before, active NIC, and here's the after, active and standby. So it's actually not that hard to use. Scroll over to our vSphere client, and you can see right here, update virtual switch happens twice. And if I scroll down, I'll need to refresh this and go to properties. In fact, actually, there it was right there, standby. So let's go to properties and confirm this right here. Double click NIC teaming, and you can see that VMNIC4 has moved down, and effectively it's moved down. So it's done. That's a pretty straightforward change. Go back over to my shell, and if we wanted to change some other things, we could do that. So for example, if I want to enable failback, or actually disable failback, right now it's enabled. So what we could do is just say P set NIC teaming failback enabled colon false, because this is how you specify Boolean values, colon and then $ false. Dramatic pause. There we go. Our settings change was made. And that is how you work with NIC teaming policies. Next up, we're going to talk about working with distributed virtual switches. So first off, I want to warn you, I mentioned this briefly before, your options are slightly limited with version 4.1. And this is basically just a maturity thing. VMware will get there. They have definitely progressed steadily. So hopefully we will see in the very next revision more support for distributed virtual switches. Not to say that you can't do anything. It's just not quite as comprehensive as it is with standard switches. So you can use the get virtual switch commandlet with the distributed parameter to filter out and examine just those distributed virtual switches. Don't forget, you can also use the pipeline. This is great for showing you membership or the relationship between, for example, DV switches and virtual machines or virtual machine hosts. So let's go, before we go back to the shell, I want to show you, in case you've not worked with DV switches before, or if you're new to them, just a very brief overview of what they look like. And these do require the enterprise license, I believe. And what we have here is, this is a DV switch, and I've got several port groups underneath it, distributed virtual port group. And they have many of the same attributes of a regular switch. The difference is that instead of being tied to a single virtual machine host or an ESX server, these basically live in the database of the virtual center, and you configure them once and then you attach them to a host server. So the paradigm is a little bit different, and the end result is that you're going to have less configuration drift and a little more of a stable environment, hopefully, and several more features by going to a distributed virtual switch. I like working with them a lot. They're really flexible, and there's some cool things that you can do, especially with private virtual LANs, which are pretty advanced things that you're, there's some cool stuff you can do, and there's a lot of great white papers on VMware.com that talk about what exactly they're for. So I just wanted to show you really quickly, if you added a distributed virtual switch, go to network adapters. This is one place that you can see that relationship, that link between a host server and the physical network adapters that are assigned to it. And you can modify that under Manage Hosts. Here you can check, uncheck, you can change, you can do migrations. So I could add, for example, another box over here, or it lets you do some things where you can migrate traffic on a current virtual or a physical network adapter to another, to a D switch. And you can also migrate virtual machine networking. So if you had a bunch of virtual machines that you wanted to, for example, move from one port group to a DV port group, you could do that using this box. And then it summarizes everything and allows you to make your changes. So you can see this is highlighted, and there it's reconfiguring the virtual machine to connect to the DV switch. So that's just your 1 minute overview of what the DV switches are. Like I said, I like them a lot. They're a really cool feature. One of my favorite that came with version 4. So let's go back over to the shell, which is right here. Got a nice clean screen. Let's start off with get virtual switch. Hit enter, and by default you can see that I see my V switches, as well as here at the top a DV switch. There's a switch from my switch. Get virtual switch distributed. If I do that, it's going to only return those DV switches. Now I showed you, or I instructed you rather, that you are unable to create a DV switch using the new virtual switch commandlet. And that's just one of the shortcomings that we have with version 4.1 of Power CLI. But once it is created, you can work with it, you can do things, you can examine what the properties are, and you can do reporting and whatever else the many things that you can use PowerShell to do. So let's start by examining this a little bit. And you can see here that my DV switch has a goodly number of ports here. Here's the MTU setting. There's a notes field. And then we have a couple of extraneous fields. Then we got the name right here. So I've got my DV switch object here. I could pipe this to set virtual switch and then do something, for example, let's see. I could try to modify the number ports, and I believe this is not going to work, but I'm just going to plug this number in. Yeah, so this is an example. It doesn't know what to do with that DV switch. You're not able to modify them in this way, unfortunately. Again, you can't make many modifications. Now, when I say you can't make any, when I use the word can't, it's a little bit of a misnomer. What I've been doing thus far in these courses is showing you how the commandlets work. That's been the focus. Just because you can't do it with a commandlet doesn't mean that you can't do it. And what I would encourage you to do is to go to the community. I believe there was a commandlet for it. Yeah, there is. Get PowerCLI community, and that just goes to vmware.com/go/PowerCLI. So in the community, under discussions, I mean, there's a lot of them here, as you can see. There are full script examples with tens or sometimes hundreds of lines of scripts. And there are, for a fact, I'm certain that there are ways to modify distributed virtual switches. And I've written scripts to do them myself. So when I say that you can't do it using the commandlets, I'm just saying that the commandlets are the short, the simple, the task-oriented way that you can make modifications to your environment without too much extra hassle. So you can do these things using PowerCLI. It's just more work. And as I said, definitely come to the community for the examples. And there are plenty of things that you can do to learn more. So that's your homework assignment, if you will. So I'm going to go ahead and close this window and get back to just showing a couple examples of things that you can do with DV switches. So I've got this one. If I want to see, for example, which of my VM hosts are connected to a DV switch, I can do that this way. So, and I can do the same thing with DVS, pipe it to get VM. So I can show which of my virtual machines actually have membership on that network. And you might recall batch is the one that I modified just a moment ago. So there's definitely some things you can do, and it's mostly more on the reporting side. Nothing you can really modify at this point or create. But as I said, this will get better. Now let's talk about port groups. Port groups are the named networks. These are the the segments of your network environment. And one of the key things that you can do with a port group, let me go back over to the vSphere client and go to my hosts and clusters, and I've got my networking configuration screen right here in front of me. The port groups are the left-hand side of a vSwitch. You can see here, virtual machine port group. There's the name, followed by the content, the virtual machines that are assigned to it. So I've got a VM network, I've got a VM kernel, I've got a management network, and those are multiple different port groups. So what we can do with port groups, I'll show you in the GUI. Here's where they show up. Double click on them. One of the most important things that you might want to do with a port group is modify its VLAN tag. There's a couple of other screens in here as well. And the security tab and the traffic shaping tab, these are things that you cannot edit easily using PowerCLI commandlets today anyway. But you can make changes to security and traffic shaping. These are going to require longer form scripts, and that's something that you can definitely explore in the PowerCLI community. So going back to what we can do using PowerCLI, using the commandlets, let's have a look at what commandlets are available. So we have several. We'll start with get virtual port group. And this is going to be the noun here. It's virtual port group. You're going to use get, of course, to retrieve information about your port groups. You'll use new to create new ones. And then we've got remove and set to remove and modify these port groups. Let's go into more detail about the get virtual port group commandlet. It has many parameters. Here are some of the most important ones: VM host, VM, virtual switch, name, data center, standard, and distributed. So all of these are filters. That makes it really flexible. If I have a large list of things and I need to help narrow it down to a smaller body. So let's check out these virtual port groups and see where we go from there. Okay, I've got my window open. Let's try just get virtual port group by itself. Okay, now got a nice large list, and you can see that this contains both DV port groups, which is easily shown here by the preface there under the key, and plain port groups or standard port groups. We've got different information about both of them. And you can see here, for example, here's a service console, VM kernel. So the VM kernel is going to be my vMotion network. I created some port groups here for iSCSI, and that's what these IP storage port groups are for. So let's have a look at some of the parameters under Get Virtual Port Group. And I mentioned these before. So let's do, for example, standard. And there we go. We've got, here's a list of just our standard, not our distributed, virtual port groups. I'll pipe this to format list. And that's going to show a lot of data. All right, I hit Control-C to stop that. So we have one virtual port group here in front of us called IP storage. Got a couple of ID parameters here. Then we've got the name of the virtual switch to which it is attached. And I can see here a port field, a VLAN field, virtual switch name field. So this is actually a duplicate. There's a couple duplicates in here. Probably one of the more useful one is going to be the VLAN ID. If you use VLANs in your virtual network or your physical network, actually, then you're definitely going to want to make use out of that VLAN ID. Okay, so let's make a new port group. So in order to make a new port group, let's first look at new virtual port group. So it has a name parameter, a virtual switch parameter, a VLAN ID parameter, and then the common parameters that all commandlets have, such as what if and confirm. So let's start off with a switch. So we've got let's use vSwitch. Let's get our virtual switches. I think I've got one called 3. Yep, that was our new one. So let's create a new port group under vSwitch 3. So let's get virtual switch name vSwitch 3 and pipe that to, actually let's scroll up before we pipe it to anything. And let's look at under new virtual port group. What I need to do is I need to figure out if I'm able to send things over the pipeline to this commandlet, because I don't know off the top of head. So I should probably check that out. So what I do is going to go to the full listing of the new virtual port group. Actually, what I can do, I can do parameters. And let's say virtual switch. Okay, so this is just an extract out of the help file. And the answer to the question is, yes, it does accept pipeline output, or input rather. So let's try that, where I was going. So let's say get virtual switch name vSwitch 3. Yes, that does return what I expected to return. Pipe that to new virtual port group name. And we'll call this how about our new PG, very original. And let's give it a couple of other parameters, such as VLAN ID 40. And let's see if there's anything else in here. There isn't. So let's start this off with a what if. And we've just got a very simple. Let's take that off and hit enter. And that's going to create 2 new port groups with the same name on my 2 virtual hosts. We go over to the VI client. We can confirm this. You can see add port group. And if I scroll down to my vSwitch 3, you can see there it is, new PG, and it's been tagged VLAN ID 40. Go to properties. There, I see it there. And we've got this, and we can, using the set NIC teaming policy commandlet, which we talked about, if I wanted to, I could modify each of these different settings. So that's all I want to show you with port groups, although you know what? Let's remove one. I've got this new PG. Let's get virtual port group name a new PG. And obviously the caps is not important because I mixed that up and it worked. So let's just hit up arrow, pipe that to remove virtual port group. And that's about all there is to it. Of course, PowerShell does prompt me because this is a big change. You would definitely not want to do that in production without being certain of what you were doing. Hit enter twice, and those new port groups are gone. Go back to my VI client. You can see remove port group, and they're gone. So I actually want to put them back in for a moment because I'm crazy like that. I want to show you what happens if you try to remove a virtual switch that has port groups in it. So let's just grab the virtual switches and pipe that to remove virtual switch. And let's see if it'll do it or not. I think it's going to axe it entirely. Okay. So the answer to the question is, do you have to remove your port groups before removing the virtual switches? The answer is no, you don't. If you remove the switch using PowerCLI, then the virtual port group is gone as well. So if you ever need to clean house, you can definitely do that using PowerCLI. So that is it for the virtual networking lesson. We talked about a lot of different things over the course of this one. Started off with an overview of some of the different aspects of virtual networking. Then we talked about all of the various different components and commandlets that make up virtual networking, everything from switches and host networks and host network adapters and virtual groups and all of that stuff. And then we went into detail about the host network, and I talked to you about the host network adapters, how we have physical and virtual host network adapters. Then we talked a lot about virtual switches and distributed virtual switches and the linkages between those and port groups. And then I showed you how to work with port groups.